Hello, my name is Benjamin Yoder, and today I will be discussing research my partner Nicholas Schulte and I conducted over the impact of weaning methods on calves in response to vaccination against bovine respiratory disease, also known as BRD. So a little bit of background information on bovine respiratory disease. It is a severe respiratory disease that is associated with pneumonia. It's also the highest costing disease among beef cattle annually. That number each year is over $900 million that is lost by the cattle industry in terms of treating bovine respiratory disease. So it can have a very, very major and severe economic impact on this industry. Now within BRD, the specific virus that's actually going to cause it is known as bovine respiratory syncytial virus, or BRSV. And that is what we are actually vaccinating against, which you can see a picture there in the bottom of withdrawing that vaccine up into the syringe. And so BRSV is the virus that is going to be causing BRD. So then some information on how the weaning process works. Traditionally, weaning is going to be the complete separation between a calf and their mother. They're put in completely separate pens and have no access to each other. This is going to have significant increased amounts of stress on the calf, and cortisol secretion then is also going to increase as a result. This is going to lead to some alterations to behavior, such as a lot of vocalizations throughout the day by the calf and refusing to eat. This can lead then to depressed immune function and increased incidence of sickness, especially with some weight loss there as well. And in an industry that is so reliant on these cows maintaining a healthy weight, that weight loss can be pretty significantly economically damaging. And that contributes a lot to some of those economic impacts that we discussed on the previous slide. So then the modified weaning method. What we have done is we have utilized nose flaps. And what these do is allow the calf to be weaned while still being able to remain with the mother. So basically that nose flap that you can see pictured up there on the right just flips down in front of the calf's mouth if they try to lean their head up to nurse. And so that allows them to be weaned, stop nursing, but be able to still stay with the mother. This has shown to decrease the stressful behavior responses that we discussed in the last slide, such as vocalizations. And then the calf will also spend more time feeding and so maintain that healthy weight, and they'll have a decrease in overall cortisol secretion. So based on this then, we hypothesize that since the nose flap weaning method has been shown to put less stress on the calf, it will have a stronger immune system and thereby a more favorable response to vaccination. So then some information on our weaning methods. So in the left there is the control group. They're going to stay with the mother and continue to nurse. They'll basically have no lifestyle change at all, very, very minimal stress, and that maternal bond will remain intact. And that's something our lab has especially focused on because that maternal bond can be very strong. And then on the right is going to be the traditional weaning group. So they will be completely removed from the mother, put to a foreign area. They'll be in the age range of 6 to 8 months, and they'll be instantly removed from nursing. Now, a benefit that is with that traditional group is that the mother will recover faster before calving again. So then, lastly, with the nose flap group in the middle, they will be able to stay with the mother still, have the nose flap installed, being around 6 to 8 months old, and once that is installed, they will have no more ability to nurse. And then after 2 to 3 weeks, that nose flap will be removed. And the benefits of the nose flap group are kind of, we can see, combined from both the control and the traditional. The mother recovers faster before calving, but it's still a minimal stress on the calf, and that maternal bond is still able to remain intact. So now a bit more information on our methods. We have 9 calves that are aged 6 to 8 months. These calves are in 3 groups with 3 calves each. They are assigned nose flap, as in the green, the traditional group, pictured in red, or the control group, pictured in blue. The vaccines were administered to all 9 of these calves on the day of weaning, which we have assigned as time equals 0. So then this here is just an ideal immune system response to vaccination, what would just be kind of the normal ideal response. Within that first curve, which is from days 0 to 21, we'll see a spike in the amount of neutralizing antibodies produced, and the first vaccine is going to be administered on day 0. And then ending at day 21, that's where the first curve ends, and then the second curve is going to start. And on day 21 is when that booster vaccine is administered, And then within that second window, we'll see another spike in the level of antibodies produced, and then that second curve will end on day 45. So the first curve is day 0 to 21. Day 21, the booster is given, and the second curve is day 21 out to day 45. So then a bit more information on our timeline. So like we said, day 0, time 0, is when the groups were assigned, vaccines were administered to all the calves, and the weaning process began. And then on day 21 is when the booster vaccines were administered. We removed those nose flaps, and that's where the first curve ends on the graph that we saw on the last slide. And then finally, on day 25, the last day that samples were collected, that is where that second curve ends. And that was all of our timeline for this study. So then our methods while we are out at JMK Ranch, we started by guiding the calves gently through the squeeze chute, which can be pictured there in the top, and that's just kind of gently restraining them. And then we would withdraw blood from the coccygeal vein, which is at the base of the tail. You can kind of feel it with your finger, and then inject the needle and extract the blood. Then we inject that blood into red top tubes and store those tubes in a cooler, and that just gives them the blood some time to clot. Then once we're actually in the lab, we're going to double centrifuge all of our samples. Most of the literature we read suggested only a single centrifuge. However, we found that by double centrifuging, we're able to get a more pure blood serum sample. And that is the next step is going to be extracting the blood serum. So basically just taking the liquid component off. And then storing these at -80°C until all the samples have been collected. Once we have collected all the samples, then we're able to warm those samples up to room temperature and perform an ELISA procedure to determine the levels of neutralizing antibodies for BRSV in the serum. And that is what the ELISA plate looks like in that bottom picture there. And that neutralizing antibody step is very key because this is what is giving us a quantitative way to evaluate our hypothesis by looking at the levels of neutralizing antibodies produced in our calves in the different groups based on different weaning methods. So now on to some of our results. So the first graph we see here is our BRSV neutralizing antibody production. So to just break a little bit of this graph down, on our x-axis, this is representing the days after vaccination. So that's going from day 0 out to day 45, like we discussed previously. That's the entire timeline of our study. And then the y-axis is going to be showing the concentration of neutralizing antibodies for BSV that are in the serum. Now, a bit of a note on that axis, it is shown in a proportion, which means that a 1 on the scale, the very top, would indicate that there was enough neutralizing antibodies in the serum to cover all the antigens that are provided within the ELISA plate. So that's kind of what that y-axis is saying. And then a note on our legend, the blue bars on the graph are representing the control group, the green bars are representing the nose flap group, and the red bars are representing the traditionally weaned group. So during those first 5 days, the first several spots on the graph, we see no significant statistical difference in antibody production between any of the weaning methods. This is pretty early on still, so not a whole lot is happening at this point. Then if we look at day 21, there is a significant difference between the control and modified nose flap weaning group versus the traditionally weaned group. In terms of those proportions that we discussed just a bit ago, the modified weaning group produced almost double the amount of neutralizing antibodies as compared to the traditional group. So a very, very significant difference there. It's also worth noting that there's no significant difference between the control and nose flap group. So those two are essentially the same. And then on the 21st day, we removed the nose flap from the calves, from that nose flap group, and boosted all 3 groups. And then if we look finally at day 45 on the curve, we can see at this point that pretty much all the groups are showing elevated levels of neutralizing antibodies, which does tend to make sense at this point. Even the traditional group that experienced the highest amount of stress is so far removed from that initial stressor, it's been 45 days at this point, that it makes sense that all the groups should have elevated levels of antibodies. However, the control and nose flap group are still showing significantly more neutralizing antibodies compared to the traditional group. So even though the difference is less at day 45, there is still a significant difference, but it makes sense that all of them should have higher levels because it's just been so long since the initial stressor. And then finally, our next slide So this slide is showing the total cortisol secretion between the groups, and the colors are the exact same as the last slide, with blue being control group, green being the nose flap group, and red being the traditional group. So on days 1, 3, and 5, there were significant differences between the traditionally weaned group and the control/nose flap groups. So on those days, the traditionally weaned group was showing significantly higher levels of cortisol secreted, and this is kind of just further reinforcing research that Southwest Baptist University presented to Sigma Zeta last year about the traditional group having higher cortisol secretion compared to the nose flap group. It is worth noting, however, that in terms of visual stress, not really any of these groups showed high levels of stress. They all seemed to be fairly calm. So visually, the stress didn't really manifest as much in terms of some of those behavior alterations we talked about earlier. However, we do still see a significant difference in the traditional group in terms of its cortisol levels. So even if they're not manifesting a lot of stress visually, there is some still increased stress happening within the body. So in conclusion, the utilization of the modified weaning techniques that reduce stress appears to demonstrate improved immune system function. This conclusion is a lot of it is drawn from the day 21 levels on that graph that we discussed earlier, where we see the neutralizing antibodies in the nose flap group as compared to the traditional group. The nose flap group has almost double the amount of neutralizing antibodies as the traditional group. So that is showing a very, very strong suggestion that using that modified technique that is less stressful is in fact leading to improved immune system function for those calves. This then improves the animal welfare by decreasing the incidence of sickness. This could even also then lead to a decrease in the use of antibiotics by the farmers, and then this could all work to increase the producer's bottom line. And this really goes back to that number we talked about in the beginning of $900 million annually cost of treating bovine respiratory disease. As much as we could possibly do to bring that number down would certainly be a good thing. And it appears that these nose flap methods that are leading to less stress in healthier calves could potentially be a way to help bring that number down a little bit and reduce the annual cost of treating bovine respiratory disease. And then just to finish off with some acknowledgments, I would love to thank my advisor and research professor, Dr. John Murphy, for the use of his cattle and ranch facilities. I would also like to thank my team members for being so helpful and encouraging throughout the entire research process, making it a more enjoyable experience. I would like to thank Sigma Zeta for not only helping fund this project, but also giving us a platform to share our results. And I would like to thank Southwest Baptist University for allowing us to use their laboratory facilities. Thank you so much for listening.